Okay, guys, you've got your notes in front of you, and I need to go ahead and extend this a bit. Um, we're talking about the distributive property today, and you guys can read over the definitions, but the important thing for us to see here is that for for all real numbers, a, b, and c, a times the quantity b plus c is the same as a times b plus a times c. And the thing that they want us to know with this definition is it doesn't matter, and guys, you know this because of commutative property of multiplication. It doesn't matter if the a comes after the quantity, like here, or if it comes before the quantity, like the first one. We still distribute. A times b is ab, a times positive c is positive c. Done. It doesn't matter which one comes first. 3 times 5 is the same as 5 times 3. Okay? Equivalent expressions. Guys, an equivalent expression is two expressions that may look different but have the same value. For instance, 9x plus 5x is an equivalent expression to 14x, right? Because we could combine those terms and just make it 14x. They look different, but they are equal, okay? And the reason that they've defined this for us, equivalent expressions, is they're going to say things like, write an equivalent expression for this, for a times the quantity of b minus c, and then you would just write ab minus ac. You'd go ahead and distribute, and that would be an equivalent expression. Okay. Now, simplifying a variable expression. This is simplifying all the time. We want to distribute if necessary. If we have something that we can distribute, we want to, because we're going to multiply before we add and subtract. Combine like terms. That's the adding and the subtracting of anything that looks alike, okay, that have the exact same variables. And then we also want to make sure that any fractions we have are reduced, okay? Simple enough. This first example is just a little trick that I use all the time. You probably do too, just to make mental math a lot easier. Example 1 says, use the distributive property and mental math to find the product. Guys, do you see that this is 5 times 80 plus 3? Same thing. But those are easier multiplication problems than 5 times 83. So, Ian, tell me, what is 5 times 80? 400, right? And then 5 times 3, David? 15. Good job. So the total is 415. Excellent. Now, Taro, this one says, I think you probably have it better on your sheet than mine. Is it 9.5? It's 9.5, right? So would you agree, Taro, that this is the same as 6 times 9 plus 0.5, or a half, if we wanted to? Okay. And then, Taro, help me out with the first one. What's 6 times 9? 54. Okay. And then what's 6 times a half, Jordan? 3. So 54 plus 3 is 57. Okay. Here's something that you guys might not know, or you may not think of it in these terms. But mixed numbers that we don't like working with anymore because it's for little 4th graders, it makes it easier for them to see. Okay? We don't really like working with them. We need to make them improper fractions. Work with them either as a fraction or a decimal. It's the mixed number that makes it hard. Okay? But this is the same as 8 times 2 plus a fourth. A mixed number is always the big number, the whole number, plus the fraction. Right? 2 plus a fourth is 2 and a fourth. All right? So, Alfredo, what's 8 times 2? 16. Good. And then what's 8 times a fourth? 2. Excellent. So then I'm going to get 18. All right? That's it. Distributive property helps us do that mental math when we take a big number and we just break it down into two things that are easier to deal with. Okay? All right. Good job, guys. See you at the next example.